All right. Well, I don't have your last homework assignment graded, so sorry I got a little behind. It's been a busy week. But anyway, you have something for me, right? We had 3 proofs for today, A20. So how'd it go?
I got stuck in the last one.
Proving 1599? Yeah. Okay. So how can I help you?
Have you do it.
Me do it. Well, how did you start? I think you should start with the left-hand side. You should start with 1 GCDB, right?
I did that.
Okay, so 1 GCDB equals by. So I think you just used the definition, right?
I did the definition.
And then 15.81.1, right? And then you have an or distributes over, and distributes over or.
And then I did it.
Now here's the tricky thing about this. Here's the next step that might be tricky. Yeah, so here's a big hint. You have some equals, right? You have something equals something and something else, right?
Yeah.
The big hint
384.
is 384A.
You should have told us on the hint sheet.
No, you needed to deal with that. You needed to try to do that yourself. Okay, so what? Here, let's look at 384A.
Twice.
Twice, yeah, you got to do it twice. Somewhere you will use 3.84A substitution. But, I mean, here's the thing. To prove 15.99, at one point in the proof, what you have is, you have something, here, you have something equals something and something else, right? Well, if you have something equals something and something else, then whatever one of those things equals the other one, then you can use that other one you can use that other one here.
Yes. Do we prove all of them by proving true implies them?
No, this one you can just start right off with 1 GCDB and get it to be, and in the end get it to be 1. And these are equals, these are not equivals, for sure, because these are all numbers,
Yeah.
integers.
I got a question.
Yeah.
How do you quote, like in the last step you end up having 1 max?
Yeah, in the end, the penultimate step, you have 1 max -1. That's by math 1.
By math?
Yeah.
Because I quoted the definition on it.
No, I think that's just math, because these are specific numbers.
All right, I was right, man.
Yeah.
That's fine.
This equals by math 1. Right. Yeah, but anyway, this is a big hint. I hope you. But now that you've struggled with it for a while, you'll remember it better than if I had just given it to you. Oh, yeah,
And I
yeah.
was like, well, there must be something.
Yeah. Well, anytime you have something equals something, I mean, did you kind of like see what you needed? Because you have one, I forget what the letter, well, let's see. I think you have D equals 1 and D divides B, right? So D equals 1 and something else, then whatever that equals, you can put that in the other expression. It equals the same thing with the equals sign. Are we good?
Now we are.
Now we are. All right. Okay, good deal. Those were good questions.
I found my binder in my book.
Okay, now what we're going to do today, what we're going to do next, for the next few minutes, we're going to prove that Euclid's algorithm is correct. So we're going to do a proof of correctness. Yes, we are. All right. So check. Okay. Yeah. Now, actually, one of the part of it's going to be an exercise for the student, but you'll see. Okay. All right. So what we have the precondition Q and we have the postcondition R, and then we have the invariant P that goes into the do. All right. So this is a really good example of how to prove
Really good practice.
program correctness. Really good practice, I think. So now, do you remember the 4 steps of what we have to do?
No, off the top of my head.
Well, then, since you don't remember off the top of your head, here they are. P.30, proof method for do. All right? To prove Q initialization, P, which is the invariant, yeah, and then do guard B, if B then S, in do, and then postcondition R, it suffices to prove these 4 things. So we have to do these 4 things. First, we have to prove that P is true before execution of the loop. So how do we do that? We prove the Hoare triple Q initialization P. Are you with me? Do you remember that? And then we have to prove that P is a loop invariant. So how do we prove that P is a loop invariant? We prove P and the guard, right? And then the statement, and then P as the postcondition also, which means P is an invariant, right? Because it occurs both as a conjunct of the precondition and as the postcondition. Yeah, but now here's the thing. Inside S, there's an if. Yeah, so how do we do that? This will be the first time we've done an if inside of a loop, but that's very common programming. Okay, and then we have to show that the execution of the loop terminates, and then we have to show that R holds on termination. So we have to show P and not B implies R. So this is a good review of, of how to prove programs correct. All right, so let's prove Euclid's algorithm. That's what we're doing. So what do we have to prove for A? Remember what step A was? What do we start off with? Or what is it that we have to prove? Q. Yeah, Q.
Initialization P.
Yeah. So how do we do that in terms of weakest precondition? By definition of the Hoare triple, how do we do that? What do we have to prove?
Q implies weakest precondition.
Yes, very good. Q implies, did you see that before? Weakest precondition, dot, now what's going to be the dot?
Initialization.
The initialization, which in this case is what? No?
XY gets
BC. Are you with me? That's the initialization. Is everybody clear on this? Yeah. Okay, XY gets BC, and then dot what?
Now it's the
Dot P.
Do you need parentheses?
No, but we'll put them there for clarity. Is everybody good? And then how do we always do this? Assume the conjuncts, okay? So what are they? So Q, Q is an abbreviation for what we have up here, right? So we assume conjuncts. So let's write them out. Let's write out what the conjuncts are. Assume conjuncts, and so conjuncts of Q, and those conjuncts are 0 less than B and 0 less than C, right? So we start off with this, right? Are we good? So we start off with WP dot XY gets BC dot P, and we're just going to keep using our abbreviation because that's why we have the abbreviation. Okay. Yeah, P. Yeah, good. Good. Yeah, P.18 for assignment, definition of assignment, and textual substitution, all in one step, will give us what?
B.
So now, yeah, it's this, right? So yeah, so what is it? Wait. Oh yeah, we have to go P. Yeah, we have to look at P. So P is that invariant, that whole invariant. So say it again. B, tell me again what's right. B. GCDC
Equals
and 0 less than B and 0 less than C. Oh, holy moly, this is trivial.
look at the conjuncts.
Here's a conjunct, and what's this? By, yeah, reflexivity of equals, right? Okay, so this equals by reflexivity of equals and conjuncts and assume conjuncts. True. Got it? Are we good?
Totally, bro.
Okay, now how about part B? Ooh. Now what do we have to do with B? What was it? What was the rule?
With the variant.
Right, but we have to throw in the what?
P and
The guard, yeah, P and the guard. Okay, so it's P and the guard equals, or sorry, implies the weakest precondition of what? Now, of what? If blah blah blah, guard blah blah blah, phi, right?
Yeah,
Okay, so we'd have to write all that out
we're good.
right here. Okay, so let's do this. Let's say if dot dot phi, and we know what the dot dot means, right? Or dot dot dot. Are you with me? It's all of that. Yeah? Okay. Oh, this implies this dot what? Dot P. Okay, so now what we're going to do is we're going to say there are two cases, right?
One if it's
Well, the two cases are x greater than y and y greater than x. Okay? So there are two cases. Yeah, we have to do both. And what'll happen is we'll do one, you'll do the other. Okay, so x is greater than y and y is greater than x. All right? Okay, so first let's do case one. And the case one is going to be x is greater than y. All right? So what do we have to, so therefore, if we do that case, then what does this turn out to be then? This turns out to be P and B implies weakest precondition dot
X gets X
x gets x minus
minus Y.
So if there
y.
was an if loop with like a bunch of different, so like 10 different statements, you just have to do 10 different.
Well, if there are 10 different guards in the if, yeah, there's one case for
So
each
we
guard.
end up using the proof method for the if statement thing? 'Cause you know how we had a proof method for that?
Yeah, that's what this is. You have to do them case by case. All right?
You're asking me.
You look so down.
No. Yeah. Guess I am.
Down?
Why don't we use P24?
Uh,
Those are not-
Question is, why don't we do, we are doing P24, aren't we?
No, we didn't.
Well, no, but he's saying for the if statement.
Yeah.
Yeah, we are. We're doing this and this and this. So we're doing Q and B1, S1R. That's what we're doing. We're doing B, we're doing each one of those separately.
Right. And then the first one.
Oh, the very first one is,
We just kind of did that without proving.
oh, I see. To be really rigorous on this, we should state that,
Do
oh,
A, B, and C. Let's do it.
no. Well,
Yeah, let's do it.
we should say that Q implies, actually, you're right. We're leaving out a step here, aren't we?
Yeah.
We are leaving out P.24a.
Can we just state that?
Well, can we just,
Do it.
well, here, let's just do it in our head.
Yeah.
What is Q? Q is 0 less than B and 0 less than
That's
C.
not Q, that's
Whoa,
not
whoa,
Q.
whoa, slow down.
Q is P.
Oh, sorry, you're right. Yes, it is P, yes. Okay, so it's, but and 0 less than X and 0 less than Y, right?
Exactly.
Yes.
All right, so doesn't that imply that X is greater than Y? Doesn't that imply that X is greater than Y or Y is greater than X?
True.
Yeah. Okay, so that was,
Good.
we're good. Thank you for not making me write that down. All right.
I'm surprised you even brought that up.
No, I mean, that's a good point. That's a very, no, to be, you do have to do
We
that.
just did it in our head.
Yes. Actually, that's a very good point. Okay, so, yeah, we,
So this is technically case 2. 'Cause
case A, yeah, actually, this is case A, and then, actually, this is case B. Yeah, actually, this is case B of the,
Wow.
yeah, okay. Well, I'm assuming that you guys can all follow this, all right? Okay, so, yeah, so assume conjunct of antecedent, all right? And so we will start with what? WP this dot P, right? So let's do that over here. So we have WP dot X gets what? X gets X minus Y dot P, and this equals by, now what do we always do here? Assignment statement. P.18 is our assignment statement. And textual substitution. Now we have to write down P, right? With everywhere there's an X, replace it with X minus Y. So look at P.
So you have X minus Y.
So you have X minus Y,
CDY
GCDY
equals B,
equals B,
GCDC,
GCDC,
and 0 is less than X minus Y,
and 0 is less than X minus Y,
and 0 is less than Y.
and zero is less than Y. Okay? So now this equals, now tell me, what does 0 less than X minus Y equivales what by math? 0 is less than X minus Y equivales what?
Y is less.
Yeah, in other words, X is greater than Y, right? All right, and we assume what? What's one of the things that we're assuming? What case are we doing here?
Oh.
We're doing case 1. So we are, that's the case that we're doing, right? Okay.
That's the B, right?
So we are assume case, so let's say assume case 1.
Yes, it is.
So if we do that, what do we have? That's true, and then we know true and, we've done this, we don't have to say identity of, and, right? Yeah, so, I mean, by now we know how to do this, right? X minus Y, GCDY equals B, GCDC, and then this goes away, and we have and 0 is less than Y, right? Oh, is that a conjunct? Okay, so this equals by assume conjunct. Do we have a conjunct of
0 is less than Y.
0 less than Y? So then that's and true, so we have X minus Y. But now we got a little work to do. Right? Well, yeah, we have to go back now, don't we?
I remember you showing us
Yeah, let's,
GCD, and that was one of
we have some GCD stuff here, don't we? That's the definition, 1592 is the definition of GCD. Which one are we looking for? Which one can we use?
It's
No, I don't think there is anything on.
You gave it to us one time, but it's not on the sheet. It's different.
Yeah, but now we have to use what's on a sheet.
Really?
Yep.
Okay.
How can we get, what's the problem? What's our problem in looking at this?
There's symmetry. We can use
Yes.
symbol 102 in symmetry.
Let's actually do symmetry first, and then we'll have the X minus Y on the other side on the right side of the GCD. Okay, so this equals by, so which one is symmetry?
1596.
Symmetry 15.96. So that we can flip these, right?
Yeah.
So that's Y GCD X minus Y equals B GCDC, but this equals by, now we,
15102.
so what does 15101 say? It says B GCD equals the absolute value of B, GCD the absolute value of C, right? So let's just go ahead and do that on this one, right? So what we're saying then is that this is
abs dot y GCD GCD abs of x minus y, are you with me? Equals b GCD c, right? Do you agree with that step in the proof? I'm just taking the absolute value of both sides, right?
Yeah.
Now, what do we know this equals by math?
Can we define absolute value anywhere?
What do we know about abs? Well, we know that that's math. Abs dot y equals abs dot what? Negative y. Don't we know that
Yeah, we do.
from math?
Oh, I know.
And that's how we can flip it. Okay?
That's shiny.
So, no, this works. So this is abs dot y GCD what? Abs,
X plus Y.
no. What's the negative of x minus y?
Y minus X.
Y minus x equals b GCD c.
Wait, how did we do that?
I took I negated this because you know that the abs of any one is equal to the abs of its negation. So I negated this. So the negative x minus y is y minus x, right?
Shouldn't that be the hint then?
Yeah, yeah, he's just.
No, this is the hint. Math
It
abs.
is arbitrary. You use just.
Oh, okay. I should not have used y. Here, yeah. Here, let me use. I don't know. No, I don't want to use x. I don't want to use x, y, or b is c.
Z.
Z. Yeah.
Z.
There.
The letter Z.
Okay. Yeah, the letter z. Are we good?
Alright. So, are we good?
That was some serious shenanigans.
Yeah, I need to change that to z. Z. Okay. So are we good here? And now what? And now equals by what?
102.
15. Well, 101 again, right? Because it's equals. Are you with me? So equals by 15.101 again. Now what is this? Y GCD what? Y minus x equals b GCD c, right?
I hate this proof.
My brain hurts.
So now we can use what? Okay, so now you tell me, now tell me what. Now we can use 102. So equals by 15
They
point.
should make a theorem that means that.
Oh, actually, it would have been ezy to,
Why don't we, why is it there?
no, I mean, yeah.
2.1.
Well, actually, what you could do is you could make a theorem for each one of these. I mean, the question is how many theorems?
Okay, that theorem will be good because it gets rid of like 5 steps.
What he's saying is have
Making a 101-2 that's switching the
x,
to a y.
what, I mean, that
Yeah, I agree.
g,
So you can have C minus B.
well, yeah, but then you'd have to do it for the left, you have to do it for the right.
Call it
no,
the
no.
identity of Tuz.
Okay, so now what? So now by 102, 15102, what do we have? Come on, what do we have here? By 15102, tell me what.
Yeah. Well, you have.
I missed that. Anyway,
Wait, didn't we already get rid of? Oh, okay.
I hate this.
y, correct, y GCD x equals b GCD c. And now what? What are we trying to get this to?
Symmetry.
Math.
Oh, what about symmetry? 1590.
Symmetry, and then you can just see the
Yeah.
quadrants, and then it's true.
Aha, so which one do we flip?
Boom.
This one?
Yeah.
So this equals, by symmetry,
Oh my.
by symmetry, 1596, x, GCD, GCDY equals b, GCD, I don't want to go to another board, so we'll start writing small, GCDC
No one in the camera.
equals by what?
Assume conjunct.
Assume conjunct,
Woo.
true. Boom, boom. Have you guys seen that? Have you guys seen that little,
Make the boom boom bigger.
okay. Boom! Okay, have you seen that little placard? It says, think ahead, and by the time you get to the ahead, they just run out of room, and the D is,
I do that all the time on my paper set.
you never seen that?
No.
Oh, come on. Here it is. It's like, here it is. Here. Think ahead.
Oh, that's good.
Get it?
That's pretty funny.
Anyway. All right. So now what do we have next? What's the next thing we have to do? Case 2, right?
Yes.
But that's a homework problem. Okay, so case 2. Now what do we have to do?
For the years to come.
Case 3.
Yeah, this is posterity. You guys better be careful what you say in here.
We have to have a picture of us on the album.
Oh, in the end? We should.
cover.
We need it.
Oh, on the album cover, you mean for the box set?
I'm so down.
Hey, you know, that would be kind of cool to have to print up a little CD
Yeah.
thing with our picture on it. That would be awesome. Let's do it. I think we should do it.
During,
Okay. You're on.
study session before the.
Oh, yeah.
Like half an
About-
hour to do that.
Yeah. Take a half an hour to take a picture? Man, you really want this to be professional. Should we hire, should we get, the okay.
Bios.
C, we're getting way off topic here. C.
It's on my phone.
This is completely on topic.
C, what's the third thing we have to do? Oh, we have to, let's go back to and now what do we have to do?
Oh, this is about reasoning.
Yeah. What do we have to do?
Doing case 2, huh?
Case 2 is a homework problem.
At some point.
We have to prove that the loop will terminate. Yes. So how do we, do you agree? Do you think that it will?
Yeah. Well, what's happening every time it loops through that would change it?
Yeah, that would change what?
Okay, so X is getting closer to Y. It really is.
It's getting closer to 0.
Well, but it doesn't terminate when it hits 0 though. So how do we prove?
Each one's subtracting, they end up evening out until
They're getting closer and closer to each other each time.
Right, but because they have to both start, in order for that to work, they have to both start out to be positive, right?
And that's in our
That's in the precondition.
precondition Q.
Okay, so both X and Y start out positive, right?
Right.
By the precondition. Okay, so both X and Y, I don't like start out, but I can't think of anything else.
Initialize.
Both X and Y are initialized,
Are positive in their incipient stages.
are positive in their incipient stages. You've been taking too many English classes. Both X and Y are initialized to positive values, and each time through the loop, what is decreased?
One of them gets closer to the other.
Well, no, the what? What does it say?
The greater one is decreased by the lesser one.
Yes, very good. Okay, each time through the loop, the larger of X and Y is decreased by the smaller.
This job would just be a copy crazy drink.
The larger of X and Y is decreased by the smaller. So now, therefore, can either one become less than 0? Can either one become less than 0?
No, not possible.
No, because you're always subtracting a lesser number.
You're always subtracting a lesser positive number from a greater positive number. So neither can become less than 0, right? So neither X nor Y can become less than 0. So that's an important observation. So, in fact, the crux of our proof depends on that. So neither, the crux, the incipient crux. So neither of X and Y can become less than 0. No, the crux of the argument.
Isn't it neither X nor Y?
Yeah, paramount.
So then neither of, all right, that's better English. So neither X nor Y, neither nor. can become less than 0. Okay? But if you subtract them each time, but neither one can become less than 0, that's, yeah, they will, okay. Therefore, the loop.
I like Ben's reasoning earlier on, because each time you subtract the lesser from the greater, you're making the difference between two of them less.
Less, and so they will eventually equal each other.
Yeah.
All right, and now what about part D? What was the recipe for part D?
R holds constant.
P, what, how did that work? What, here, what did we have? We had to prove that this happens, that,
P and not B implies.
yeah, because the guard, in order to get out of the loop, the guard has to be false.
Yeah.
So P is our loop invariant. We already proved that that's a loop invariant.
Right.
So it's P and
Still has to imply that
that the post condition holds. So what we have to do is we have to prove P and not B implies what? R. Is everybody clear? And we are going to assume the conjuncts of the antecedent. Obviously, that's the way we always do it. And so we have, so one conjunct is not B, another conjunct is all the conjuncts of P, which are X, blah, 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 right? So assume conjuncts. And we'll start with R and get it to true. Are you with me? So R equals, by definition of R, here's our definition of R. Are you with me?
Yeah.
Okay, so it's X equals Y equals B, G, C, D, B, G, C, D, C. But now what's the meaning when we have equals here? No, you were right.
Yeah,
Kyle was right.
Yeah,
It's the conjunctive meaning.
right.
Okay, so this equals by conjunctive meaning, X equals Y, and Y equals B, G, C, D, C. Are you with me?
Yeah.
Yeah, and what about our not B?
That's X equals Y.
That's X equals Y, okay? So we assume assumption not the guard,
So you
right.
couldn't do that without separating it?
right? Assumption not B,
And 339.
which is X, which is not X is not equal to Y, which is X equal. Yeah, and true, and we know true and, yeah. Is everybody with me? Is that what you're saying? So what we're left with is Y equals B, G, C, D, C, right? Y equals B, G, C, D, C. But now what? So this equals by assumption X, G, C, D, Y equals B, G, C, D, C. Okay, so what does that make it? Y equals X, G, C, D, Y. Now what? This is cool. How can we mess with this X?
Make it Y, G, C, D, Y.
Ha-ha, because what is our assumption? Not, yeah, our assumption that are not guard, right? So this equals by our assumption, this is way cool. By our assumption, not the guard, right? Again? No, it's not. So this is Y equals what?
YGCDY.
Y, G, C, D, Y. But don't we have a Y, G, C, D, Y theorem?
That's identity.
Yeah, but what is that? 15 point what?
890,
No, I think we have, it's going to be a little tricky here. Is there a Y, G, C, D, Y?
No,
Come on, you
it's not
guys.
the absolute value.
Ooh, whoa. We're going to have to mess with absolute value again? Oh, dear.
No, this is fine though, because we already know that.
Aha, with math, right? So 15 point what?
15.98.
15.98.
And we know that it's
And
greater than
assumption.
Okay, so this is going to be Y equals what?
Y equals absolute value of Y.
Yes. Y equals abs dot Y, right?
Yeah.
But what do we know by our assumption?
Y greater than 0.
Yes. Our assumption is that Y is greater than 0, and math, right?
So we know that
And math tells us that the absolute value of y, if y is greater than 0, is what? Y. So we have y equals y. Equals by reflexivity of equals true.
Now, is that cool or is that cool? I think that's way cool. We proved that Euclid's algorithm is true, is correct.
He was very smart.
Yeah, before his time, you're right, before computers, right? Okay, see you on Monday, and then we only have 2 weeks left.
Yes.